Transportation model. Transportation model has three methods. First, the northwest corner cell method. Second, least cost method. And third is VAM or vehicles approximation method. So before proceeding, we have here four given: the source, the destination, the supply, and the demand. So first, we determine if the given is balanced or unbalanced. To know that, we look at the supply and the demand column and row, and we total both. So if both result to the same value, the problem is balanced. If unbalanced, add a dummy row or column to make it balance. So we will tackle all the methods, but we have here one common problem so that we can compare the results. So we have here four destinations, three sources, and on the supply rows we have 300, 400, 500. On the demand row we have here 250, 350, 400, and 200. So let's not forget to check if the problem is balanced or unbalanced. In this case, both the supply and demand has a total of 1,200. This means that the problem is balanced, so we do not need to add a dummy row or column. So first, we will solve the problem using the northwest corner cell method. For the first step, we need to find the northwest corner cell. As you can see, cell 1A is the northwest corner cell. Second step, compare which of the cells demand or supply has a lower value. Comparing demand and supply, demand has a value of 250 and supply has a value of 300. So 250 is lower, so we are allocating 250 for cell 1A. Third step, subtract the lower value for both supply and demand. So we're canceling all of the cells for column A since 250 minus 250 becomes 0. And 300 minus 250 becomes 50. After that, we just have to repeat steps 1 to 3 until all of the cells are cancelled. We now have successfully allocated all of the cells, and the cells are cells 1A, cell 1B, cell 2B, cell 2C, cell 3C, and cell 3D. For step 5, we get the total transportation cost. We get that by multiplying the allocated demand or supply value to the cell value. So 250 times 3 plus 50 times 1 plus 300 times 6 plus 100 times 5 plus 300 times 3 plus 200 times 2, and it will give a total of 4,400.
Transworld Moving has been hired to move the office furniture and equipment of Cohen Properties to their new headquarters. What route do you recommend? This is a shortest route problem. So our starting point is old office and our ending point is new office. So you can see I have 3 routes, one in blue, one in green, and one in pink. So in the blue, we start from 1 to 2, then 2 to 5 since there are no other alternate routes. And in the 5th, I have the choice of going to 7, 8, or 6. But I chose to go to 7 because it's shorter. There are only like 1, 2, 3 more steps. If I go down to 6, it is 1, 2, 3, 4 more steps to get to 13. And if I go to 8, it's 3 steps, but 120 is smaller than 130. So I chose to go to 7. And in 7, I have the choice of going to 10 or 8. If I chose 8, I have to go all the way down to 9. It will add more steps. So if I chose 8 and I go to 10, it will still add. So I chose 7 to 10. So it's less steps. And from 10, we go straight to 13. And you can see in root 1, we have a total of 480. Root 2, I go straight to 3, and then I have an option of going to 5 or 4, but I chose 5 because, like in the previous route, less steps. So in 5, same as route 1, I chose 7, 7 to 10, and 10 to 13. And in the last route, no, for our second route, we have a total of 430. So in the last route, I chose the shortest. I chose 4 since we've done 2 and 3. So 1 to 4, and then 4 to 6. Because if I chose going to 3, it will add more steps. 4 to 6, 6 to 9, because if I chose 5, again to add more steps. 9 to 11, and then 11 to 12, then 12 to 13. And with that, you have a total of 490. So as you can see, we just added everything from 1 to 2. Route 1 to 2 is 100, 2 to 5 is 100, 5 to 7 is 120, 7 to 10 is 60, and 10 to 13 is 100. And that is a total of 180. Just the same with the rest, we added it all up. And as you can see, the shortest route we had is route 2, which is 430.
Assignment problem is a special kind of transportation problem in which each source should have the capacity to fulfill the demand of any of the destination. The main objective is to assign the jobs to the right operator such that the total processing time is to minimize. The matrix entries represent the processing times in hours, so we can see there are 5 operators and 5 jobs. The minimum value of our first row is 7. For our second row is 6. For the third row is 6. Fourth row 9. And fifth row is 7. So this will be the results. So we will now find the minimum value of each column. For the first column we have 0, second column 0, third column 0, fourth column 2, and fifth column 0. So we subtract and now we get these results. To cover all our zeros, we need to do row scanning. For row scanning, check if there is exactly 1 0 in the row. Otherwise, if there are 2 or more, skip the step. Mark the zeros with a square and draw a vertical line passing through that zero. We can see there are zeros left, so we need to do column scanning. With column scanning, draw a horizontal line passing through that zero. We can see that we have 4 squares and 5 rows, so it is not equal. So we now proceed to step 3. We need to add the minimum undeleted cell value at the intersection points and subtract it to all undeleted cell values. For the remaining deleted cell values, stay as it is. So we now get these results. So there are 5 number of squares, which is now equal to the number of rows. Hence the solution is optimal and feasible. So we will write down the optimal solution. For job 1, 2, 3, 4, and 5, to identify its operator, check the squares that is allocated in each operator. So for the time, we check our initial matrix where the squares are allocated, and by adding them, we get the total processing time of 38 hours.
That's all for this video. Thank you so much for watching. Don't forget to like and subscribe. Till next time!